Hello everyone. Let's start with the basics of data mining. Data mining is essentially extracting patterns and knowledge from large databases. It's about finding hidden insights that can help us make better decisions. So, what exactly is data mining? It is the process of discovering patterns, correlations, and insights from large datasets. It uses methods from machine learning, statistics, and database systems. Key characteristics of data mining includes extracting implicit and previously unknown information. It handles large volumes of structured and unstructured data. It identifies relationships not obvious to human analysis. And it supports data-driven decision-making. Let's explore some common data mining techniques. First, we have classification. This predicts categorical class labels based on training data, assigning items to predefined categories. For example, email spam detection or customer churn prediction. Next is clustering. This groups similar objects into clusters without predefined classes. Objects in the same cluster are more similar to each other than to those in other clusters. For example, customer segmentation or document categorization. Regression is another important technique. It predicts continuous numerical values based on input variables, modeling relationships between dependent and independent variables. For example, price prediction or sales forecasting. Lastly, there is association rule mining. This discovers interesting relationships between variables in large datasets, identifying frequent patterns, correlations, or associations. For example, market basket analysis or product recommendations. Now let's dive deeper into classification algorithms. Popular one is decision trees. This is a tree-like model of decisions where each internal node represents a test on an attribute. Each branch represents an outcome of the test, and each leaf node represents a class label. Here's a simple decision tree implementation in Python using scikit-learn. We import the decision tree classifier, create and train the model using the fit function with training data, and then make predictions using the predict function with test data. Another powerful algorithm is neural networks. These are computing systems inspired by biological neural networks that learn to perform tasks by considering examples, without being explicitly programmed for the specific task. Here's a simple neural network in TensorFlow. We create a sequential model with dense layers and specify the activation functions. Then we compile the model with an optimizer. Now let's explore some clustering techniques. K-means clustering partitions data into K-clusters where each observation belongs to the cluster with the nearest mean. It minimizes within-cluster variances. Hierarchical clustering builds a hierarchy of clusters by either a bottom-up, which is agglomerative, or top-down, which is divisive approach, creating a tree-like structure of clusters. Then we have DISCAN, density-based spatial clustering of applications with noise. It groups together points that are closely packed, marking points in low-density regions as outliers. Here you can see an example of K-means clustering visualization. Let's take a closer look at association rule mining. Association rule mining discovers interesting relationships between variables in large datasets, identifying frequent patterns, correlations, or associations among sets of items. Key metrics to evaluate the rules are support, confidence, and lift. Support measures the fraction of transactions that contain both item X and item Y. Confidence measures how often items in Y appear in transactions containing X. Lift is the ratio of observed support to expected support if X and Y were independent. For example, consider a market basket analysis. Suppose we have 4 transactions. T1 contains bread, milk, and eggs. T2 contains bread, diapers, and beer. T3 contains milk, diapers, and beer, and T4 contains bread, milk, diapers, and beer. A discovered association rule might be if customers buy diapers, then they also buy beer. In this case, 75% of transactions contain both diapers and beer. 100% of customers who bought diapers also bought beer. A strategic product placement can increase sales. Let's explore some real-world applications of data mining. In financial services, data mining helps financial institutions detect fraud, manage risk, and personalize customer services by analyzing transaction patterns and customer behavior. Examples include fraud detection in credit card transactions and credit risk assessment for loan approvals. In healthcare, medical institutions use data mining to improve patient outcomes, optimize treatment plans, and identify disease patterns from large clinical datasets. Examples include disease prediction and early diagnosis, and treatment effectiveness analysis. In retail, retailers leverage data mining to understand customer purchasing behavior, optimize inventory, and create targeted marketing campaigns that increase sales. Examples include customer segmentation for targeted promotions and inventory management and demand forecasting. And in web and social media, online platforms analyze user behavior and content to improve user experience, recommend relevant content, and detect trends or anomalies. Examples include content recommendation systems and sentiment analysis of social media posts. Finally, let's discuss some challenges and future trends in data mining. Current challenges include privacy and security, which involves balancing data utility with privacy protection and ensuring compliance with regulations like GDPR and CCPA. Big data scalability, which requires processing and analyzing extremely large and complex datasets efficiently and in real time. And ethical considerations, which includes addressing bias in algorithms and ensuring fair, transparent, and accountable data mining practices. Future trends include artificial intelligence integration, which means deeper integration with artificial intelligence and machine learning for more autonomous and adaptive data mining systems. Edge computing, which involves moving data mining closer to data sources for real-time processing and reduced latency in Internet of Things and mobile environments. And explainable data mining, which focuses on development of techniques that provide clear explanations of how results are derived, increasing trust and adoption. As data continues to grow exponentially, data mining will remain a critical discipline for extracting valuable insights, with increasing focus on ethical considerations, privacy protection, and explainable results. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.